Yeah, so quiz today, later. Test next week. Next Thursday is November 10th. That's our test on Chapter 4. And any other announcements? Oh, so there'll be an online quiz set up. You know, I've noticed some students they're not doing too good with their online quiz. Maybe they don't know where to find it. I thought maybe I'd turn on the computer and show you, but when you're in my math lab, I'll just tell you maybe, when you're in my math lab, you can go to assignments like you normally do. There's a box called assignments, I think, and you can click on it and you can look at, I think you can look at all assignments. Anyway, way down at the bottom after all the homework, there's the quizzes show up. So some people haven't been finding them. But the other way to find them is go to quizzes and tests. I think there's a button called homework assignments or quizzes and tests assignments. Anyway, if you click on this one, then you can see them. They're right there. So maybe you know that. But everybody, I've got a few classes that are kind of mixing that up somehow. But I'll make that announcement to everybody. Yeah, so we're sort of finishing up Chapter 4. If I picked up where I left off, I'm in the middle of 4.4. But maybe you got something else you want to talk about. Do you have any questions or concerns anywhere? Okay. Well, let me do this then. I'll talk about 4.4 a little bit. Maybe I'll back up a little bit before we stop and take our quiz. Our quiz is not too long today, so maybe 30 minutes is good for that. So the last, let's see. So when we were in 4.4, one problem we did was we were trying to solve what we call. So let's just. I'll review a little bit of what I did last time. Solve a radical equation. Look at this. I found one in the book here. This might be in your homework as well. The square root of x minus 10 equals the negative square root of x minus 20. The square root of x minus 10 equals the negative square root of x minus 20. I just found this problem in the book, in my book. And you know, yeah, we did this last class, barely. Solving radical equations. So we learned that, oh, okay, these equations have square roots. To find x and get rid of x, or to find x and get x by itself, we need to get rid of these square roots. So there's this concept of square both sides. So we square both sides. Now this one I picked today is about the worst one. Maybe it could get a little worse. But this is about the worst one. We didn't do one of these the other day. The problem with this is it has these two radicals. And one of the things we said is, well, if you're going to square both sides, you should get one of the radicals by itself. Then when you square it, it just pops out, you know. So that's totally cool. I mean, this radical's by itself. So maybe I should just go ahead and square both sides right now. This will just sort of pop out, I think. But over here, when you square both sides, you do not square each term. That's the phrase. The phrase is not square each term. The phrase is square both sides, which means you grab the whole side and square it. So anyway, back to this side a second. You know, when you square the negative sign, it's positive. And when you square the radical, it just pops out. Bleh. Whatever's inside comes out. So over here on this side, I think the answer is x minus 20 after you square it. But squaring this requires you to FOIL it. You know, you do not square each term. You do not square each term. You FOIL it out. Now, how many millions of times have I done this? Let me say something. When you FOIL a binomial, you do not square each term, but what you always get is this pattern. The first term is squared, the last term is squared, but there's always a middle term, which is the product of those two times 2. So there's a middle term called 2ab. Now, I don't know, have I ever told you that pattern? I think I've just foiled them out, and maybe you remember that pattern. You don't have to remember the damn pattern. You can, it kind of helps. But, you know, this is a plus b times a plus b, and you could just do the foiling. If you do the foiling, you get here. So I could just do the foiling and get here, but I like the pattern because it saves me a little time. The pattern is, you do square him, but there's a middle term. The middle term is the product of those two doubled. Now what's funny about that is the product of those two is negative 10 times the square root of x. If you double it, it's negative 20 times the square root of x. And the funny thing about this is we were squaring both sides to get rid of the radical. We still got a radical. So we were squaring both sides to get rid of the radical. We did, we got rid of that radical. But in the foiling process, we sort of got rid of a radical, but we sort of still got one. So we still got a radical. So guess what I have to do? Square both sides again. But first, get this radical by itself. All right, so hang on, let's get this guy by itself. What do you want to do? Subtract an x? That's going to be sweet, actually. This is not as hard as I thought. When you subtract an x, they're gone. Subtract 100. If you subtract 100, that's negative 120 over there. What's going on here? Negative 20 square roots of x. I want to square both sides to get rid of this radical. I could do that now. It would be pretty smart, actually, though, to divide by 20 first. Divide by negative 20 first, maybe. Divide by negative 20. Divide by negative 20. Now I got the square root of x equals 6. I think now I'll square both sides again. I already squared both sides once, and now I got to square both sides again. This is easy now, though. Squaring the square root of x gives you x. Squaring a 6 gives you 36, and I think that's my answer. That wasn't that bad. I think they can get a little worse, maybe if this is a little more complicated. This was kind of a nice little square root. The fact that both those x's canceled made it nice. Otherwise, I would have had more squaring to do over there. More foiling to do. You know, if this x wouldn't have canceled, I would have had more foiling, right? It's more. Right, so that was actually kind of nice. Don't forget, though, when you're squaring both sides in order to solve a problem, you should always check your answer. Because you could produce false answers. And nothing I did was false or wrong or incorrect, but the answer could just be wrong. So I'm going to go back to the original problem. Let me see what I've got here. I got the square root. I'm going to plug in a 36. The original problem before it was squared was the square root of 36 minus 10. Does that equal the negative in front of 36 minus 20? Well, let's see. That's a 6 minus 10. 6 minus 10 is negative 4. What's going on the other side? 36 minus 20 is 16. Inside the radical, there's a negative sign out front. That's interesting. That's good, actually, because the square root of 16 is a 4, but the negative sign makes it a negative 4, so it checked. So that is a legitimate answer. It's the only answer I got, and it checked. So that was pretty good. You know, sometimes you get quadratics. I mean, sometimes at the end, this was easy here right at the end. But I did have this square both sides issue. Any questions? You guys all right? Well, if I continue in 4-4, then one of the things that comes up next is some different types of inequalities. Now, and right off the bat, you know, I shouldn't say this, but we have these absolute value inequalities. So I'm making up an absolute value inequality here. Now, Well, so right off the bat, I'm not that big a fan of these, but I did include them in your homework. But I don't always see the point of these problems. So but if I included them in your homework, I should teach you a little bit about them. Will they show up on the test or not? We'll see. We'll talk more about that next week. But absolute value inequalities. Part of the reason I don't like them is because the best way for me to teach them is just to tell you to be a robot and do what I do. Don't even think. Promise me you won't think. No, I'm sort of kidding. But the prescription to solve this is this. Take it out of absolute value and sandwich it in between 17 and negative 17. What I just did there was I took this out of absolute value and said it's less than or equal to 17, but at the same time, it's greater than or equal to negative 17. I feel like I made a sandwich between 17 and negative 17. It's a sandwich. Maybe you should think of this absolute value as a sandwich. Made a sandwich. Now, have we ever solved these things these are called compound inequality? Yeah, we did this a little earlier this semester. We just did some of these. You would add 5, try to solve for x, you would add 5 to all 3 sides. We did this. That leaves x in the middle by itself. This is 22 and this is negative 12, I guess. And that's the answer. On a number line, the answer is between 22 and negative 12. It's a lot of numbers. It's all the numbers in between negative 12 and 22. So what did I tell you to do? If it's an absolute value inequality, less than problem, the truth is, if it's a less than problem, you make a sandwich. If it's a greater than problem, you got to approach it a little differently. A little differently. And that's kind of the part I don't necessarily like to teach. So you know what? Let me say it. Let me say this. Let's do this a whole different way. Sometimes I like to teach inequalities like this. You know what? You can't trust inequalities. Inequalities you can't trust them too much. So can we just pretend, watch this, this is different now. Can we just pretend that this is an equal to problem for a second? And if it's an equal to problem, do you know how to solve this? Well, this was back a chapter or two ago, and I taught it to you briefly. I think at the time I said I didn't like this either, so maybe you didn't even do it much. It never showed up on a test. But the idea was easy. If you remember, the idea was you set the x minus 5 equal to 17, but you also set the x minus 5 equal to negative 17. And then you proceed to solve. Now what are you going to get? When you add the 5, you're going to get 22. And you're going to get, when you add the 5, you're going to get negative 12. See, so when you solve this, you get those same 2 answers. Those are the same 2 answers I just got. And maybe I should put them on a number line. I'm saying I can't trust the inequality. I couldn't trust the inequality. Well, I can if I do it like that. But I could put these on a number line and just and then try to test which region makes the inequality true. This is a different approach. Watch this. Let's test this region. Pick any number you want in this region. Pick any number you want between negative 12 and 22. What would you pick?
4.
4. That would work. I'd pick 0. But you can pick any number you want. All right, now what do I want to do with that number? I want to test it. Go back to the original inequality. Remember, this was an inequality. And plug in a 0. If you plug in a 0, you get the absolute value of negative 5, which is 5. Is that less than or equal to 17? Yes. Okay, then it's true. It's less than or equal to, so it's true. All right, if this test number came out true, that means it's true for all these numbers, so this is the shaded region. And so now you know that the answer for x is between these numbers. X is between 22 and negative 12. And by the way, I guess you could test the other regions, but if this one's true, the other ones are false. All right, I'm talking about absolute value inequalities. I sort of taught you how to do it. Then I taught you this other way, which is ignore that it's an inequality. Just get your answers, put them on a number line, and test. Now here's the truth, if I just sum it up for you. When it's less than inequalities, it's going to be the middle area. If it's a greater than inequality, you can do all the work. Maybe you could try it this way, although that's dangerous. You could try it this way. When you do the test, this is going to be the answer. It's going to be these answers and not the middle. So you can sort of memorize that. Again, you could try a little homework. I don't think I'm putting this on a test. But I am doing this one. You ready? Here comes some more inequalities. So that's absolute value. By the way, at the end here, I just summarized it. What the hell did I just say? At the end, I summarized it. If it's a less than inequality, it's the middle stuff. If it's a greater than inequality, it's the outer stuff. It's the wings. Kind of makes sense, too, by the way. If it's less than, it's inside here. If it's greater than, it's outside those regions, those numbers. But let's do these. Let's get out absolute value. I'm not a big fan. What about this? This is quadratic inequalities. So here I am now at the end of 4-4 here, kind of. And, we got a week to get good at this for the next week's test. Quadratic inequalities. Watch this. X squared minus 4 is less than or equal to 0. So it's quadratic inequality. What should I teach you? What should I teach you? There's a lot of different ways to teach you this. I think I'm going to just tell you that when you can't trust inequalities. Listen, look, when you have 3x plus 5 is less than 15, I mean, do you know how to solve this inequality? Yes. And the truth is you totally can trust this inequality. So you can trust little linear inequalities. You move the 5 over, 3x is less than 10. You divide by 3, x is less than 10/3. That's the answer. And you keep in mind that if you ever divide by a negative, you better switch the inequality symbol. But you can totally trust that. It works. But once you go to quadratics or absolute value, the rules get a little weird. And so that's why I'm suggesting you can't trust the inequality. So if you can't trust it, what am I saying? Here's what I'm saying. Let's pretend it's not an inequality. Let's pretend it equals 0. Let's solve and get our answers. How would you get your answers? What would you do?
Move the 4 over and then take the square root.
All right, he's going to move the 4 over. I like that. Take the square root of both sides. The answers are plus and minus 2. Plus and minus. Don't forget, when you square root both sides, that's plus or minus. Cool. We got our 2 answers. So they go on a number line, and they are, a positive 2 and a negative 2. And the final answer, though, it was, if we remember back a few seconds ago, it was an inequality. And the final answer is some shaded region. And maybe it's that middle shaded region. Maybe it's these outer shaded regions. But so at the end, after I got my answers and I put them on a number line, I can test to see which shaded region is true. It's easy to test. You just have to pick a test point. Like I said, watch this. I'm going to pick 0. If I pick 0 and plug it into this original inequality, I'm plugging in a 0 for x. It's a test. It's a little test number. If I plug in 0, what do I get? Negative 4 is less than or equal to 0. Now, is that true? Negative 4 is less than 0? Okay, yes, that's true. If it's true, you shade that region. And that's the answer. Maybe I need little help writing my answer. My answer is all the numbers between -2 and 2. My answer is all the numbers between -2 and 2. X is less than the 2, but at the same time it's greater than or equal to the -2. It was equal to, so I'm including that. I could write my answer like this, of course. Hey, what did I say about these absolute value guys? Remember I said if it's less than, it's the middle area. If it's greater than, it's those outer wings. That's kind of true with these dudes, I think. Maybe it depends. Maybe it depends on the signs. You better watch that. You better not. You better watch. You better test. You better test stuff to see which region it is. I mean, it's weird, right? It's an inequality, and then I change it to an equal sign. I mean, and the only reason I do that is because I'm telling you, you can't trust this. Watch. What if you tried to trust it? What if you said, "Well, I'm just going to leave it there. I'm going to trust it." Okay. Well, then you've got this less than symbol here, right? And then when you square root both sides, you got this less than symbol right here. So now what's going on? Is it less than or equal to 2, or is it less than or equal to -2? I mean, I'm not. This is misleading and actually kind of wrong. We already know the final answer. The final answer is it is less than the 2. It's less than the 2, but it's not less than the -2. It's greater than the -2. I mean, that's not what that says, but that's what this says. It's greater than, it's less than the 2, but at the same time, it's greater than the -2. It's between the -2 and 2. And this, and following, just leaving this inequality symbol here and trying to trust it just doesn't work. So it needs to be sort of tested. Or there's another approach. And I like this approach. You could approach this very visually. You guys, this is a parabola. And when we set it equal to 0, remember a few minutes ago I said ignore the inequality. We wanted to know what. So this is, you could pretend this is a parabola. We set it equal to 0. What did we just find when we did this? When you set a parabola equal to 0, you found, what's the word for those things? When you set the
y-intercept?
Well, the x-intercept. When you set it equal to 0 and solve for x, we just found the x-intercepts. All right, hang on a second. We got a parabola, and I just found the x-intercepts. Hang on a second, hang on a second. Now, this is my parabola. Look, does it open up or open down?
Up.
It opens up. In fact, I could think a little bit more about this parabola. I could think about it as being a parabola that's shifted down 4. It's shifted down 4. So it's this parabola that's been shifted down 4. But what I got is his x-intercepts here. He opens up. He's been shifted down 4, but he opens up. Now look at this picture and tell me, when is the parabola less than or equal to 0? Look at the picture. When is the parabola less than or equal to 0? And what 0 is the y-axis, you know? 0. So when is it below the y-axis, or when is it above the y-axis? Maybe this is a cool approach. I like this approach. It's very visual. Maybe you don't even have, well, we still have to find the x-intercepts. Maybe. But, so when is it below the y-axis? It looks like it's below the y-axis when it's between -2 and 2. Right, that's the answer. A third way, you know. Here it is again. If this problem said, I'm switching it on you, I'm sorry. If this problem said greater than, then look at the picture. When is the parabola above the y-axis? When those legs stick up out over the y-axis. So when x is on this side of 2, right? Greater than or equal to 2. Or when x is on this side of -2, it's above the y-axis. The x-axis.
I was going to say, is it...
Have I been saying y-axis all this time?
Yeah.
Yeah, sorry.
And I was wondering...
What the hell am I saying? This is the x-axis, sorry. Yeah, that was bad. Erase the tape. The x-axis. The x-axis. I've been saying y-axis all day.
Mm-hmm.
Jesus.
My confidence.
Yeah, I should. Yeah, I'm telling you, that'll mess everybody up. It's the x-axis. You know what the name of the x-axis is? It's called y equals 0. Maybe that was where my brain was having a disconnect there. It's called y equals 0 is what it's called. It's the x-axis. So when is the parabola above 0? When is the parabola above 0? When it's above the x-axis. Sorry, when it's above the x-axis, which is when x is greater than 2 or when x is less than or equal to negative 2. So the less than problem was the middle stuff, and that's kind of how you write it. The greater than problem is the outer stuff, and this is how you write it. You write x is greater than 2 or x is less than or equal to negative 2. And if you pay attention to this, it's different than that. This one, x is greater than or equal to the 2. Over here, x is less than or equal to 2. It's a sandwich in between the two numbers. This is clearly not in between the two numbers if you read this. I hope. It's the wings of this thing. That's kind of what these inequalities come out to be. If there's two answers, it's either the stuff in the middle or the stuff on the wings. And you can sort of memorize that the less thans tend to be, but yeah, you better be careful. You better be careful. Here, let's do another one. Look at this guy. Wait a minute. All right, so here's an inequality, and it's a quadratic inequality. You guys can try it. I'm going to hit pause. Sorry,